Measure airflow cubic feet per minute quickly and accurately with the heating, ventilation, and air conditioning temperature rise formula by using supply minus return temperature and heater wattage, while safely setting your amp clamp to read only the electric strip heat leg so you do not cook the numbers or yourself. For electric heat air handlers, the cleanest method is temperature rise cubic feet per minute equals heater output, British thermal units per hour, divided by 1.08 times temperature rise in degrees Fahrenheit, and heater output British thermal units per hour equals measured kilowatts times 3,412. Put the system in heat strip mode only and confirm outdoor units are locked out, so you are not mixing heat pump capacity with electric strip heat. Place one fast response thermistor probe in the return airstream before the blower and another in the supply plenum after the heat strips, but upstream of any bypasses or branches. Seal around the probes so you are not reading room air. Let temperatures stabilize for at least 5 minutes, then record a rolling average over 60 seconds to smooth noise. Use a true watt reading from a power meter if available. If you must use current and voltage, measure each heat strip leg separately, multiply line voltage by current for each energized strip, and add them to get total watts. Convert watts to kilowatts, multiply by 3,412 to get British thermal units per hour, then divide by 1.08 times the measured temperature rise to get airflow cubic feet per minute. If the temperature rise is extremely low, recheck for bypass leakage, blower speed settings, dirty filters, and electric strip staging before trusting the cubic feet per minute number. Keep notes of blower tap or percent setting, filter condition, external static pressure upstream and downstream of the blower, and which strips are energized, so repeat tests are apples to apples. One of the biggest heating, ventilation, and air conditioning airflow measurement mistakes is clamping your amp meter around a bundle that includes blower or transformer conductors, which produces bogus current, bogus watts, and therefore bogus airflow cubic feet per minute. Fix it by identifying the single electric strip heater lead, isolating it from other wires, and clamping only around that one conductor. One of the common temperature rise calculation errors is using nameplate kilowatts instead of measured watts, causing search engine optimization targeted airflow calculation and temperature rise formula results to be off. Fix it by verifying which strips are actually energized, measuring line voltage at the heater, and measuring current per strip with your clamp on a single conductor. One of the safety and accuracy issues in how to use an amp clamp searches is energizing the air handler while positioning the clamp, which risks shock, arc, and a dropped meter. Fix it by de-energizing the disconnect, setting your clamp range and orientation first, routing the single heater conductor cleanly through the clamp, securing the meter, stepping back, and only then restoring power for readings. BigHomeProjects.com lists vetted heating, ventilation, and air conditioning contractors who understand airflow testing, temperature rise calculations, and safe amp clamp practices, so homeowners can get accurate diagnostics without guesswork. Contractors use BigHomeProjects.com to showcase credentials, win local leads for airflow balancing and electric heat troubleshooting, and book more of the right jobs with customers who value precision and safety.